Hi, this is a talk re-recorded, originally delivered on May 9, 2022 at an event organized by Anna de Panay-Greenberg, member of the European Parliament, an event dedicated to the regulation of clear-cutting in European forest. And it was my task to speak about ecological effects of clear-cutting. If we look at the continent, using data provided by the University of Maryland, the Global Forest Change data set, we see a lot of tree cover loss all over the continent, unevenly distributed in different intensities, and we see different forms of the patches, which partly reflect, of course, the distribution of forest. We can also appreciate that in some regions the tree cover loss seems to be more intensive. For example, here there's a interesting patch in central Germany. We can also see that in some countries, such as Sweden, this is southern Sweden, the whole landscape seems to be covered by tree cover loss. So it's worth exploring this region, and to begin here in Sweden with a randomly selected area in central Sweden, where we do not have much land use apart from forestry. So if we go closer, we see this colorful image which indicates that yes, we have small, more or less small clear cuts all over the place, and the different colors indicate the various years in which the clear cuts occurred. So from yellow 2000 onwards, orange, red towards more recent years, and then blue, the 2021 patches. So to verify how does this look like, we have a closer watch at the satellite images and quickly travel through the 2 decades, starting in 2000, where we see, yes, this is an area that has already been under use. We see scratches and patches of cutting, clear cuts in a very irregular regime, and this should reflect, possibly forest ownership, and where we then see, okay, this cutting makes progress into the landscape, and that more and more forests are cut over time. We would also appreciate that the older cuts are greening, so there's a certain succession going on, regeneration, but after 2 decades, not any clear cut would recover the original green, meaning status which is forest. If we look at other regions, such as here in Poland, we see more regular patterns, but again clear cuts, regular stripes, one next to the other in different years. So with the forest use moving through the landscape back and forth in a way, creating such a situation with even-aged stands next to clear cuts, where we have a certain regeneration with pioneer trees such as birch, but later on being replaced by planted pine again. We see the result of this silvicultural treatment of the forest. So this is a very homogeneous, even-aged stand, a monoculture in the very sense of the word, and this is a very simplified version of what could be forest and would be entirely different. We would expect a mixed deciduous forest in this region. Jumping again to another region on the map. This is central Germany, where we see a lot of red, meaning recent tree cover loss. In the mid-elevation mountains in Germany, the forest cover has been fragmented a lot. We see a lot of small patches, but bigger extensions of forest in these mountain ranges, originally covered mostly by deciduous and mixed forests, but then being replaced by spruce plantations. And it's the spruce which is suffering in recent years from drought, heat, bark beetles, the classical cascade of monoculture degradation. Wind throws being involved, and then we get this type of landscape. Well, not automatically, but here another step is producing this type of view. Of course, it's the salvage logging, the clear cutting, which now is happening in Germany, in a country where we supposed that clear cutting had been overcome for a long while, and now it's reappearing due to the salvage logging practice, with a lot of bare soil being exposed to ever more extreme weather conditions, and where regeneration is difficult, at least of trees, and we see these places becoming covered by grasses and herbs and other plants which are not trees. The clear cutting and salvage logging is happening regardless slopes and expositions and size of the areas. It's making rapid progress. We are talking about hundreds of thousands of hectares being harvested in this way after dieback of spruce and sometimes also other forest types. So the area then suffers severe additional impact, which comes on top of the forest dieback, which is related to the heavy machinery and the driving on the soil compaction and so on, everything that cannot be avoided if timber is collected in such an industrialized way. Often the intensity is even higher of this manipulation of the sites when foresters decide to extract really the entire biomass, including roots, and preparing the ground for planting by plowing and by pushing off the humus-rich upper layer of the soil. This is astonishing, as we might recall a huge body of literature that clearly indicates that clear cutting is problematic, that there are negative impacts on the soil structure, on the porosity, which then is related to the ventilation, related to the water retention capacity. Clear cutting changes the soil properties chemically and physically, and leads to the loss of soil carbon and organic compounds. So there are carbon emissions created. These areas become carbon sources, CO2 sources, for a long while before then the ecosystem starts to recover. And the reduced water storage capacity is also combined often with the reduced infiltrability, and all this can complexly lead to a reduction in regeneration, which would be related to the germination of trees and root formation and tree growth. The physical and chemical changes of the soil are also triggered and promoted by the microclimatic conditions. So it is well established that clear cuts lead to changes in soil temperatures and hydrology, and also leading to a different regime of evaporation. A critical factor here is increasing vapor pressure deficit, so the air is becoming drier and also dries out the remaining vegetation. So this change of the environmental characteristics on the clear cuts, of course, is also impacting biota, fauna, flora, fungi, microbiota, and this in times where we start to recognize the importance of the microbiome, and not to forget the organisms that are so functional in developing, maturing forest soils, including earthworms, nematodes, and other species. So it may not be too astonishing that trees have difficulties to establish themselves. Planting is the now prevailing practice to re-establish forest or to create new forests, potentially better adapted to climate change, but the problems are enormous, and the mortality of seedlings is very high, especially in these times in which we observe ever more extreme microclimatic conditions, and where all the substrate which can mitigate the extremes, which is mainly the deadwood, has been extracted. So again, these microclimatic conditions, if now applied to large areas, can even become mesoclimatic problems. Whilst we well understand like how forests cool the landscapes, are able to mitigate a little bit and buffer the extremes that are related to the global warming, and the opposite of biomass-rich forests, which are cool and more moist and have important eco-hydrological functions, is the clear cut at the other end of the spectrum. It is investigated. We ourselves have done some research on it, how the cooling capacity of forests is reduced, the buffering capacity is reduced. We did this here in boreal forests of European Russia, and where we clearly can say that the hot days, the number of hot days doubled on clear cuts, and that the cooling capacity on clear cuts was reduced up to 14%, and the buffering capacity suffered even more than that. In the same region, in the Arkhangelsk region, we also noticed that there was secondary impacts of the clear cutting, or at least it seems to be plausible. So there is a small-scale diffuse dieback of trees, and which seems to be spatially related to the clear cuts. So there are edge effects and effects on the landscape level. Whatever the reasons would be, this can be related to temperatures or to hydrological regime, and which means that there's a secondary impact of the clear cutting affecting forests beyond the clear cut itself. I would like to come back to the temperature effects and discuss the microclimate at a little more detail. So here we have a look at a recent clear cut in central Germany, in Rhineland-Palatinate, and we have a drone picture on the right hand side indicating the temperatures. So this is an infrared camera showing that where we still have trees, we have relatively low temperatures, below 20 degrees, and this would be here. When the trees have died, of course the area is warmer, but still there is a cooling effect of the even the dead trees. When we have open, cleared and salvage locked areas, we have the highest temperatures. So this goes up to 35 degrees and more than that, and fine structures can be recognized. This is related to the water content of the soils, of the vegetation, amongst others. So whenever we have a little bit of herbaceous coverage, this already contributes to cooling. This is another view on temperatures of an area that has seen a lot of clear cuts. This is in Hesse in Germany. This is the landscape here, where we can see these patches without vegetation, most of them representing clear cuts and a few also being agricultural lands. And on the right hand side we have an image showing the land surface temperature based on Landsat imagery, so using red, near infrared information for getting the temperatures of the surface, above the surface, around noon when the satellite is flying over the area. And we see bluish areas which are relatively cool if compared to the average of the temperature of this region, and reddish, yellowish, reddish colors indicating temperatures above average. The temperatures actually here represent the mean value of hot days, meaning hotter than 20 degrees Celsius in the year 2020. So, and then we see some polygons here which we have been looking at with numbers. These numbers stand for years in which the clear cutting occurred. So we see different ages of clear cuts and can see that very recent clear cuts are amongst the hottest places, but also some years before, 3 years old here, 2017, we have high temperatures, above 30 degrees, whilst the dense and still vital forest can be cooler than 20 degrees in this region. So we do not have water bodies, which usually would be the coolest places, but here it's vital forest. And then we look at other places, 2016, still very warm, 14, still above average, and we notice that for quite a few years, clear cuts heat up much more than the average landscape, and of course they contribute to landscape warming. So here we still have an equal representation of clear-cut and forested areas, but we can imagine that size matters, and the larger the clear-cut or bare areas, the more intensive the heating effect. And we could also assume that this then would hamper the regeneration of trees on the clear cuts. So this is a dynamic process. We shall not take this only as a snapshot, but we should try to understand the vicious circles that are moderated by various feedback loops, which have been described, for example, in this paper on land atmospheric feedbacks during droughts and heat waves, and where we see that a critical factor or is the vapor pressure deficit, which increases when the evaporation decreases and the temperature increases. This vapor pressure deficit stands for the hunger of the air to take up water, meaning this is physiologically very relevant, because a high vapor pressure deficit means that the air is drying out, for example, plants, no, and leaves, and also is an air which does not allow for precipitation. So we get also a decrease in precipitation, which then would further contribute to the land desiccation, a decrease in evaporation, and so on and so forth. So we see here various feedback loops and see that hydrology and vegetation are interacting, and potentially this can lead to a critical state of hot, dry, and landscape where dieback and lack of regeneration prevails. This also would be a landscape which becomes vulnerable in terms of forest fires, hot, dry, and then if this hits forest stands which are homogeneous, which are not showing any resistance against fire, we get forest fires, and this is spreading this risk even in regions where originally we did not see so many forest fires. The last example was from Germany, but even Sweden saw quite a few forest fires, a steep rise actually of burned areas in the last year, especially 2018. And if we look at the places, this is not only forest fires, so this is fires in stands next to clear cuts. This is vulnerable monocultures and remnants of forest being exposed to extreme weather and new types of risks. So in this moment we shall ask the question, so where is this leading to? If 2018 is a preview to the situation that we might have more often and more pronounced, and we had these years 18, 19, 20 in Central Europe representing a series of extreme years. All the hot years, as we know, occurred in the last decade. So will this be the new normal? What does this mean in the context of what we just discussed? And what will be the effect then of clear cutting and salvage logging? Practices that worked in a way in the last decades, so like you could clear cut the forest and then it came back, it grew back. But what if, due to microclimatic feedback loops and the whole story of increasing vapor pressure deficit and so on, this means that clear cutting accelerates the biome change from forest to non-forest? No, because actually we are attacking the system on various fronts. We are changing the soil properties by clear cutting. We are taking out the biomass, the dead wood, which still would mitigate the extremes, and then we have a changed microclimate, and we lose capacity of the soil related to organic compounds, humus, by the way, leading to greenhouse gas emissions and all these eco-hydrological changes, the loss of the green water and an ever-increasing heat and drought stress and loss of biota, which then triggers reduced growth, reduced regeneration capacity. We lose more forest areas, we lose more ecosystem services, and this is then again related to emissions, but not only. We have increased vulnerabilities to the extremes. We see more calamities more frequently and bigger calamity areas where then the typical management leads to more clear cutting and salvage logging, and then we go into a critical spiral of degradation of soils, of vegetation, of resilience, and this under rising temperatures and increasing extremes. So why is it necessary to talk about ecological effects of clear cuts in European forests in the 21st century?